Hi, my last video I talked about normal CDF. I put this information in Canvas, by the way. Now I'm going to talk about inverse norm. So kind of think normal CDF is when you're asked to find a probability percentage or area. Inverse norm is one of these cases. So I was going to look at a couple of these from the homework examples. The first one is the first one listed there. Okay, so if you look at this one, it says the graph depicts a standard normal distribution, and they give you the area to the right to be 0.7734. So by the calculator, to use our calculator, we have to find the area to the left, not the area to the right. So if this is the area to the right, I'm going to take 1 minus that to get to the area to the left, because that's what the calculator asks for. So 1 minus that gives me 0.2266. So I want to put area to the left, 0.2266. And then some of your calculators you have to put the 0,1 in. Some of them you don't. So let me show you this one. That's why this one I didn't put the 0,1. But let me show you this one in the calculator. So the way I find the inverse norm is the same place as a normal CDF. I go to second distribution, and I look at number 3. This is a newer calculator, so this one, it defaults to 0, 1, but some of the older calculators, they default to that if you don't put that in. So I'm going to put 0.2266, that's the area to the left. And then 0,1. And I get negative 0.75. Okay, so there's that example. I want to do this one as well. Okay, this one got kind of cut off here, but it says thermometer readings have a distribution with a mean of 0 and standard deviation of 1, so it's standard normal. So I'm going to go ahead and draw that here. It says 2.3% have thermometers that are too high. Okay, so that's over here. So that's 2.3%, so I'm going to put 0.023 for that. And another 2.3% are rejected because their readings are too low. Okay, this time they give us a percentage, and they want us to actually find the values. So kind of going back over this, here whenever they give you a percentage area, and they want you to actually find the value, then you can use inverse norm. I'm just going to do one of these. I'm going to do this one because this one's a little bit harder. Okay, so let's say I want to find what number goes right here. I'm doing this one right here, by the way. This one I'm not going to explain because I think that's a little bit easier. That goes along with that one. I'm going to do this one. Okay, so to find this one, I have to find the area to the left. This is the area to the right. So this is the area to the right. To find this number right here, I'm going to take 1 minus the area to the right. This is the area to the left. And then 0,1, and from there we get our answer. Let me just go ahead and plug that in the calculator. I'm going to pause and plug in the calculator. I went ahead and put inverse norm, area to the left, 0,1. And I did get the answer of 1.99, which makes sense because if you think about 0 being here, this should be a positive number, this should be positive 2, and this should be a negative number. Okay, now let's go down to this last one. This has to do with critical values. So this is this part right here. They talk more about it in the PowerPoint. So critical value, whatever number you get here, that automatically means the area to the right. So if it's z.03, that's automatically the area to the right. I always want to find area to the left. So how did I find this? I took 1 minus area to the right. So even if this is like z.05, there's an example in the PowerPoint, you're going to take 1 minus that to find this area. So it's the area to the left. And again, you can either put this in with your older calculator, Or if I go ahead and do this one, I'm just going to pause and plug in my calculator. Actually, I might just do it here. So I go under distribution, inverse norm. Area to the left is 0.97. And then for this section, the standard normal, the mean is always 0, the standard deviation is always 1. So you get 1 point. Ooh, I did something wrong, didn't I? Let me do it again. Okay, so I'm sorry, the area left is 0.97. I put 0.87. There we go. Okay, so that pretty much takes care of 6.1 for the homework. You could probably go from there to do the homework from 6.1.